From triumph over smallpox to the battle against COVID-19, vaccines have saved countless lives. But despite being hailed as one of humanity's greatest scientific achievements, vaccines have become a victim of their own success. Why? Simply put, vaccines are painful. A pain so dreadful that for many of us, it makes us question the effectiveness of vaccines. But have you ever wondered why vaccines cause so much pain and soreness that we all dread to endure? What if it's more than just a side effect? That's what my research aims to find out. You see, a vaccine works by introducing a harmless version of a pathogen into our body so that we can train to learn how to fight against that pathogen. And together, these components of a vaccine cause a localized inflammatory response as a sign that our body is mounting immunity. And as a result, we may experience pain. But that's not the end of the story. The experience of pain is so tightly connected to our sensory nervous system. Specialized cells in our sensory nervous system, called nociceptor neurons, can sense pain and also respond to pathogens, just like our immune cells. Our research has shown that these nociceptor neurons have the ability to activate in response to vaccines. Not only that, but they have a heightened pain sensitivity in response to those vaccines. So what does this mean for the effectiveness of vaccines? Is pain necessary for us to effectively mount immunity? To answer this question, we measured the immune response success. And one of the greatest parameters to evaluate the success of immune response is antibody production. What are antibodies, you ask? Antibodies are proteins that help our body to remember a pathogen so that when we encounter that pathogen again, we can fight it off. We used mice that could not feel pain, mice that were insensitive to pain, and we showed that these mice have lower antibody production, which means that our body's best defense system was diminishing in response to vaccines without pain. Pain seems to be essential for building immunity. So, how much pain is too much pain? This is what we aim to find out next. We will delineate the precise mechanisms by which these neurons can contribute to the effectiveness of vaccines. And by delineating that, we can answer the question of whether vaccine pain is our friend and it helps us build immunity, or if it is our foe and that we need to reduce that pain to build more effective and desirable vaccines. Now, I know that pain might be getting on your nerves, quite literally, but let's not be too quick to judge it until we reach verdict. After all, it may be essential to building long-term immunity. Thank you.